Imagine flipping a switch at home and watching power flow without a utility bill, without fuel, without charging. High voltage. It sounds like science fiction. It sounds impossible. And yet, right now, people around the world are experimenting with a device many are calling the Magmo Generator. But before we go any further, let's be very clear about one thing. This is not a promise. This is not a guarantee of perpetual motion. This is an experiment, one that's raising serious questions and attracting intense curiosity. So how did we get here? For decades, we were taught that energy must always come from somewhere. Fuel, sunlight, wind, batteries. The laws of physics are clear, energy is conserved. And yet, throughout history, breakthrough technologies have often appeared first as impossible ideas, ridiculed before being understood. The Magmo Generator sits exactly at that controversial edge. At first glance, the setup looks almost too simple. A compact assembly, rotational components, magnetic interaction, no combustion, no visible fuel input. And yet, when activated, something unexpected happens. Motion sustains longer than anticipated, output readings fluctuate in unusual ways, and observers begin asking uncomfortable questions. Is energy being generated, or is it being accessed? Builders who attempt this at home describe a moment of silence before activation, then movement. Smooth, consistent, almost calm. Multimeters show output, sometimes modest, sometimes surprising. Nothing explosive, nothing flashy, just quiet operation that challenges assumptions. Of course, skeptics immediately step in, and rightly so. They ask, where are the losses? What's the hidden input? Is the measurement flawed? Is magnetic hysteresis being misunderstood? These are valid questions. Essential questions. Because real innovation doesn't survive hype alone, it survives testing. That's why those attempting this build aren't calling it a miracle. They're calling it a learning device. A way to explore how magnetic fields, rotational inertia, and system efficiency interact in ways we may not fully appreciate yet. And here's where it gets interesting. As builders refine the setup, adjusting magnet spacing, reducing friction, changing coil geometry, patterns begin to emerge. Runtime improves. Stability increases. Output becomes more predictable. Not infinite. Not magical. But unexpected. This leads to a deeper question, one that changes everything. What if the future of energy isn't about creating power from nothing, but about wasting far less than we ever thought possible? As the experiments continue, something becomes clear to everyone involved. The Magmo Generator isn't about breaking the laws of physics. It's about confronting how narrowly we may be interpreting them. Builders begin documenting everything. Friction coefficients, heat loss, magnetic drag, coil resistance. Nothing is assumed. Everything is measured. Each small adjustment teaches a lesson. Remove a tiny bit of friction and runtime improves. Balance the rotor more precisely, and stability increases. Optimize magnetic alignment, and energy losses decrease further. This is where casual curiosity turns into serious investigation. Because when inefficiencies are stripped away piece by piece, the system starts behaving in ways that feel unfamiliar. Not impossible, but unfamiliar. The generator doesn't create energy from nothing. Instead, it challenges how efficiently motion and electromagnetic interaction can be sustained once waste is aggressively minimized. And that distinction matters. Many revolutionary technologies were misunderstood at first, not because they violated physics, but because they used physics more intelligently than existing designs. Early electric motors were mocked. The first airplanes were dismissed as toys. Even modern electric vehicles were once considered impractical fantasies. The Magmo Generator forces a similar conversation. What if the real breakthrough isn't free energy, but ultra-efficient energy circulation? What if systems can be designed to recycle motion, reduce losses to near zero, and operate far longer than traditional models predict? At this point, more advanced builders step in. They add sensors, data loggers, high-speed cameras. Everything is recorded. When output drops, They ask why. When stability increases, they trace the cause. This isn't belief, it's iteration. And slowly, the narrative shifts. This stops being about viral claims and starts becoming about education. Home builders report something unexpected. Even when output is modest, the learning value is enormous. The Magmo Generator becomes a hands-on lesson in electromagnetism, mechanical efficiency, and systems thinking. People stop asking, "Is this magic?" and start asking, "How can this be improved?" That question is dangerous, in the best possible way. Because once people start improving efficiency on their own, innovation accelerates. Small improvements stack. Insights cross-pollinate. One builder's friction fix inspires another's magnetic redesign. Progress no longer comes from claims, it comes from collaboration. And then the biggest realization hits. If a simple DIY system can inspire this level of curiosity, discipline, and experimentation, what happens when universities, research labs, and professional engineers apply the same mindset? Because revolutions don't begin with answers. They begin with questions we're brave enough to ask and patient enough to test. And the Magmo Generator, whether it proves groundbreaking or simply enlightening, has already done something remarkable. As more people take notice, the conversation widens beyond garages and workbenches. Online forums fill with schematics, test results, failures, and refinements. Some builds stall quickly. Others surprise their creators. And that contrast becomes the most important lesson of all. Results vary because understanding varies. Experienced engineers watching from a distance begin to recognize something familiar. Not a violation of physics, but a pattern seen whenever efficiency approaches its practical limits. At those edges, small design choices matter enormously. Alignment, material quality, tolerances measured in fractions of a millimeter. Details that are easy to ignore suddenly decide whether a system performs poorly or unexpectedly well. And this is where the Magmo Generator quietly shifts roles again. It stops being a device and becomes a framework for experimentation. Builders start comparing notes across continents. Different magnetic materials, different bearing systems, different coil arrangements. Some designs fail spectacularly, and those failures are just as valuable as the successes. Every breakdown exposes where losses still hide, where assumptions fall apart, and where theory needs revision. What emerges is a sobering realization. Modern technology wastes far more energy than most people realize. Heat, vibration, friction, drag, tiny inefficiencies multiplied millions of times across global infrastructure. When a small DIY system makes those losses visible, it changes how people think about power altogether. This is why serious researchers remain cautious, but interested. Because even if the Magmo Generator never delivers unlimited energy, it still highlights something profound. Efficiency is an untapped frontier. One that rarely makes headlines because it doesn't sound dramatic, yet quietly determines how much energy the world truly needs. And here's the twist few expected. As understanding grows, builders stop chasing endless output. They start chasing predictability, stability, repeatability, systems that behave the same way every time under the same conditions. That's when experimentation becomes science. Claims fade. Data takes over. Graphs replace guesses. Logs replace excitement. And slowly, credibility begins to matter more than clicks. Some prototypes are disassembled and rebuilt from scratch, not to chase miracles, but to remove assumptions. Others are retired entirely, their lessons absorbed into new designs. Progress doesn't look viral anymore. It looks patient, which leads to the most important moment in this entire story. The realization that energy breakthroughs don't arrive as explosions. They arrive as quiet improvements that compound. If tomorrow's power systems waste half as much as today's, if machines recover energy we currently throw away, if efficiency becomes as valuable as production, then the world changes, not overnight, but permanently. And standing at the center of this growing curiosity, the Magmo Generator remains what it always truly was. Not proof of free energy, not a hoax to dismiss blindly, but a mirror, forcing us to confront how much we still don't understand and how much potential remains locked inside the systems we take for granted. And as that question lingers, something subtle but powerful happens. People begin looking differently at everyday machines, motors, generators, fans, even household appliances. They start noticing where energy leaks away as heat, noise, vibration, wasted motion. What once felt invisible now feels obvious. And that shift in perception is irreversible, because once you see inefficiency, you can't unsee it. Some builders take lessons from the Magmo experiments and apply them elsewhere. A motor rebuilt for lower friction. A generator redesigned for smoother magnetic transitions. A system that doesn't produce miracles, but performs noticeably better than before. Small gains, yes, but gains that stack. That's when the real value becomes undeniable. The Magmo Generator was never the destination. It was the doorway. A doorway into questioning assumptions that have gone unchallenged for decades. A doorway into understanding that progress doesn't always come from new energy sources, but from respecting energy more intelligently. And quietly, without announcements or headlines, the tone of the conversation changes. It's no longer about unlimited free energy. It's about energy humility, about admitting that our models are incomplete, that our designs are often careless, that efficiency has been treated as a side note instead of a priority. Some viewers will still dismiss it outright. Others will cling to exaggerated claims. That's inevitable. Every emerging idea travels through noise before it finds clarity. But for those willing to slow down, test carefully, and learn honestly, something far more valuable than hype emerges. Understanding. And understanding is dangerous because it spreads. It moves from garages to classrooms, from DIY projects to engineering questions, from curiosity to competence. And once enough people start asking better questions, systems begin to change. So no, this isn't the end of the story. Because the real experiment isn't the Magmo Generator. The real experiment is what happens when ordinary people stop accepting energy waste as normal and start believing that better is possible, not through shortcuts or miracles, but through patience, precision, and relentless curiosity. And as that experiment continues, a quiet responsibility begins to surface. Because curiosity, once awakened, demands discipline. Some builders realize that repeating results matters more than impressive claims. They begin sharing not just what worked, but what didn't. They talk about dead ends, false assumptions, measurement errors. The conversation matures. It slows down. And paradoxically, that's when progress accelerates. This is where the Magmo discussion separates into two paths. One path chases headlines, bold promises, dramatic thumbnails, instant certainty. The other path does something far less glamorous. It tests, documents, and waits. History shows us which path actually moves humanity forward. In that second path, people begin revisiting fundamental questions. How do magnetic fields really behave under continuous rotation? Where exactly does energy loss concentrate, and why? How much of what we call impossible is simply unexplored optimization? Universities haven't announced anything. Corporations haven't issued statements. And that silence is telling, because real breakthroughs rarely arrive with noise. They arrive gradually, through replication, peer scrutiny, and uncomfortable revisions of existing models. What's undeniable, though, is this shift in mindset. For years, innovation was framed as more power, bigger grids, larger batteries, faster charging. But now a parallel idea is gaining quiet momentum. What if the future belongs to systems that need less instead of more? Less loss, less friction, less waste. That idea doesn't feel dramatic, but it's revolutionary. Because a world that wastes less doesn't need miracles. It needs precision. And whether the Magmo Generator ultimately becomes a footnote, a teaching tool, or a stepping stone to something greater, it has already triggered a valuable change, one that can't be undone. It made people question. It made them measure. It made them look closer. And once that happens, the story no longer belongs to one device, one design, or one claim. It belongs to anyone willing to test ideas honestly, accept results humbly, and refine systems patiently. Which is why this isn't the conclusion. Because as long as there are questions about how energy moves, how motion is sustained, and how waste can be reduced, the experiment continues, quietly evolving in workshops, classrooms, and minds around the world. And that is where this story finally pauses. Not with a claim, not with a promise, not with a miracle, but with a shift in perspective. The Magmo Generator did not deliver unlimited free energy, and it never needed to. What it delivered was something far more valuable, a reminder that progress doesn't always come from breaking the laws of physics, but from understanding them better than we did before. It showed that curiosity still matters, that efficiency still has room to grow, and that questioning assumptions is how innovation actually begins. Whether this path leads to new designs, better systems, or simply sharper minds, one thing is certain. Once people start looking closely at how energy is used and wasted, there's no going back.